So let's go ahead and get started. I'm excited about the afternoon session as well. So our first speaker is an invited to talk about the Moon to Mars Space Weather Analysis Office.
No, thank you so much for inviting me. Can you see my screen?
I can. Perfect.
Okay, let me move this away from my screen.
And I'll let you
So,
know when you have about 2 minutes to talk.
okay, thank you. So thank you again for inviting me to give this presentation. I apologize if you already have seen most of the slides. I've been presenting about the office in many conferences and workshops in the last 2 months. Um, I'm Jari Collado-Vega. I'm the director of the Moon to Mars Space Weather Analysis Office. And this is an office that was established in 2020 during the pandemic and is in close collaboration with the Community Coordinated Modeling Center and the Space Radiation Analysis Group track from Johnson Space Center. Let's see if I can go forward. There we go. A little bit on the background as NASA plans missions beyond the low Earth orbit, the needed improvements for space weather, modeling capabilities, communications with radiation risk to the crew, and also space weather real-time analysis have been deemed essential. The NASA Space Radiation Analysis Group, TRAG, serves as the main space weather monitoring support for all U.S. crew members aboard the ISS. They operate the console that include the imagery and also the analysis of the energetic particle radiation. Given the new challenges with these deep space missions, additional support is needed in analyzing the space weather environment, especially beyond the Sun Earth line. That's where the Moon to Mars Space Weather Analysis Office comes in. In the statement, we have that we were established to support NASA's SHRAG group with human space exploration activities by providing additional expert analysis on the space radiation environment. And I want to pinpoint the additional part because NOAA SWIFC will remain and still remains the primary forecasting office for SHRAG. This is not going to change. We're not here to step in the toes of anybody. We're actually providing a secondary expert support by analyzing state-of-the-art space weather models that are actually tailored to SHRAG needs. So we're gonna help SHRAG make informed decisions of SCP event likelihood, intensity, and duration for those human exploration missions to the moon and then in the future to Mars. We encompass both the moon and Mars missions. This is a unique capability that only an in-house NASA office can offer. And we're actually currently collaborating really close with the MAVEN team to validate the space weather events that actually sent towards Mars. Now, in terms of activities and change of events, we monitor right now currently models and activity 8 a.m. to 4 p.m. daily. This includes holidays and weekends. This is going to change when we go to Artemis launches and actually mission critical time. We're going to be 24/7. Notifications are sent out to an internal list when thresholds are exceeded. We have a 10 a.m. video tag up. It's also in person when it was possible each weekday. And then we have another 10:45 a.m. tag up with SHRAG that is actually focused on the radiation environment. Officially, we do not support the ISS EVAs, but we're actually doing it to practice for those future EVAs that we're actually going to be officially supporting. We also send a weekly space weather reports every Wednesday. And these are the events that we actually send the notifications for, the flares, and actually the instrumentation and the missions that we use, SDO and GOES. For CME, depending on the speed, we use the different chronographs available, SOHO, stereo ahead. Unfortunately, we don't have stereo behind anymore. So I did energy particle events like SOHO, GOES, and we also analyze in different locations like stereo ahead, CME arrivals, also at L1 and also at other locations. Geomagnetic storm, we use the KP index as a global index for calculating the geomagnetic storm. Radiation belt electron flux enhancements at GOES, and we also try to understand and analyze magnetoprops crossing to geosynchronous orbit using the SWMF model from the University of Michigan. Now, a little bit going back to the background on how this all started. SHRAG and CCMC have a project that is called the ICEP project, the Integrated Solar Energetic Proton Alert Warning System. And it started in 2018. And the idea of the was to transition research SCP models to operations. The prior aim to identify and transition all those models that could actually be used in real time, and then develop software for SHRAG and to implement those capabilities in the CCMC non-operational prototype. Now, CCMC has transitioned more than 6 real-time models, and they have built the SCP scoreboard. You have a snapshot there of the intensity one. And it's an application that it's going to be used operationally by SHRAG and N2M for human missions beyond LEO. The scoreboard is already being used by SHRAG and N2M for ISS support and will be used for Artemis. This is a public available tool that everybody can see. It actually has all the models there that can actually produce a forecast in real time of the events. And it's actually in this one compared to the real-time observational data from GOES. We also have the all clear SCP scoreboard and also the probability scoreboard. Now, what is actually the partnership between CCMC and M2M? We were actually the former experimental group that CCMC had for space weather. We transitioned out, now we're our own entity and office. And the idea is to create a NASA in-house research to operations to research pipeline. So CCMC is going to be always in charge of ingesting the models, talking to the model developers, and changing the models in a way that they're ready, kind of ready for that operational environment. They put them in the share environment within CCMC, SHRAG, and M2M. And then M2M grabs those models with the model developer permission, and they actually analyze and use the models in real time. So we're actually getting to the nitty gritty of the models and doing the analysis in real time to make sure that the models can be used operationally. I just want to point out that SWIFT is still there because, like I said, they're going to still be the primary office for that. We're just going to supply that additional support and eventually in the future collaborate with SWIFT so they can have all the tools that they need for the operational analysis. Now, the M2M team partners really close with CCMC. We actually are the ones that populate Donkey. We are the ones that submit the simulations, analyze the measurements for the CMEs, everything that happens in real time. We also populate a CME scoreboard. So what happens is we actually are the ones analyzing the environment, and we're using the CCM tools to actually provide that all that analysis to the public. We will continue to support NASA robotic missions as we did from many years ago, with space weather notifications and assessments and anomaly analysis support. We partner with SHRAG and CCMC in model validation. And like I said, the goal is to establish that NASA in-house R2 or O2R pipeline. Now, what does it mean doing this in real time? Well, my team analyzes the space weather environment in real time. We do the measurements of, for example, CMEs. This is actually the event that happened last time in January that had an SCP event associated with it. You can see the CMEs here. Actually, there's 2 CMEs simulated here. This is a WSA envelope plus cone model. And you can see here the sun, the CME being ejected. It was not actually an Earth-directed CME, but because of the magnetic field configuration and connectivity to the Earth, it actually caused an ACP event at Earth. We submit the simulations. We then ingest the Donkey, the database, with the measurements of the CME, with the simulations and everything. And this actually helps populate then the SCP scoreboard. We have models that actually are initiated by the data, the observational data, but we also have models that are initiated by the CME measurements. And we also have models that are initiated by the simulations that are run with those CME measurements. And here you can see an example of that population of the SCP scoreboard intensity here with the CME that we actually measured. After that, then we take those measurements and we actually help in the validation. This is a table that SHRAG created that actually shows a little bit on why that additional support is needed. You have to understand that we're talking about normal ISS operation plus everything else. So you will have a normal ISS operation, a free space mission, then you have a space weather event, then you have a lunar surface mission, and then you have, in the future, a planetary mission. So there are many locations and definitely different things that can happen, especially going to solar maximum. So the additional support is definitely needed. The primary support is still going to be NOAA SWIFC, and then M2M is going to come as a secondary support. Now, something that is really important about the team that we do is that we do support NASA robotic missions with anomaly analysis, and this is really, really important. They're requested several times a month, and I can say like this month has been a little crazy because of the solar activity. An assessment is prepared and sent to the evaluation board where critical decisions are made. We have supported many missions, and you have them right here. We also work closely with the Mission Resilience and Protection Program from Goddard. They have us as part of the regular procedures when they have an anomaly. You know, we're part of the checklist of things that they need to check. The support has been really good for new development missions like Go series, and then during shutdown, we're an essential team, which means that we still have to work. And it's actually really important because even the last shutdown, we had a mission that had a problem and they needed to know what was going on because they needed to make a critical decision about it. So this is something really important that we do and that we're really proud of. Now, something really unique about the team that I want to highlight is like we have that capability beyond the Sun Earth line. I think this is the only team that actually does that in terms of we analyze the sun 360 degrees. And this is an example of Ingenuity support. 2 days before Ingenuity's first flight, a solar flare was observed, which had a CME associated with, which was predicted to arrive the day of the second flight.
2 minutes.
Okay, thank you. When this all happened, you know, the JPL team contacted us. Shrag also was involved in the situation. And then also we involved the solar orbiter because actually the CME was going to arrive at solar orbiter first. Because of the predictions that we had, we could actually manage to understand and analyze how the environment was going to change due to this CME. And we could actually send that information to the JPL team and say, you know, we think nothing's going to happen. You should be okay. And then the decision with them, they made the decision that everything was going to stay normal, nothing was going to change. So this is something really important that we actually have, that we actually can support NASA robotic missions across the whole solar system. Another thing that we actually supported was the space, the launch of the James Webb. We're very proud of it. It was something really, really intense, but we actually had a lot of fun with it. We actually supported this analyzing the space weather environment that had to do with activities like solar flares, coronal mass ejections, solar energetic particle events, electron fluxes in the outer radiation belt, and geomagnetic storms and substorms. On the week of the launch, we provided every day tag ups and also written reports to the James Webb team. And at this time, you know, we work usually 8 hours a day. We were working 12 to 18 hours. On the day of and the eve of the launch, which is Christmas Eve and Christmas Day, we participated in the call that they have live, that we were actually analyzing the space weather 24/7 at this point. End to end, we monitor the availability of the CCMC models due to that could actually support the launch. And also we were contacted all the time with CCMC and also the stereo team. So we're very grateful of them supporting us in this activity too. And, you know, we have been still supporting the mission with post-launch operations and anomalies, just to make sure that everything's okay. So in summary, this is one of my last slides. Given the new challenges, additional support is needed. This whole has to do with the deep space exploration missions. And End-to-End will address it by analyzing state-of-the-art space weather models tailored to Shrag needs. And it's an additional support that's definitely needed. We're collaborating with CCMC to create that NASA in-house R2O O2R pipeline. And we will continue to support NASA robotic missions with the space weather assessments and anomaly analysis. We look forward to collaborate with other NASA mission groups to validate the predictions that we're making. And we're also looking forward to, as always, getting in the details and nitty-gritty details of the models, so they can actually, you know, at some point be ready for the operational environment and actually collaborate better with those operational organizations like NOAA. So this is the team, and this is my last slide. Thank you so much, and I'm here to answer any questions.
Thank you so much. That's a fantastic talk.